जावेद, इसको क्लोज कर दूं मैं अभी? जावेद, इसको क्लोज कर दूं मैं अभी? Okay. Okay. Good morning, friends. So, okay, there is still some. Yeah. Okay. Good morning, students. Those who are joining us online from Haldwani and Nainital, and students from Dikshant International, and hello, sorry, Longview. Oh, great! You could join us. Great, great. So, so it's nice to have you all over here, and this is our second day of our National Science Day celebrations. Okay, many of you might have joined us yesterday, and you must have already have got a brief background of what we do at ARIES, or who we are and why we are celebrating this National Science Day. And yesterday our theme was about sun, which our director, Professor Dipankar Banerjee, talked about. Our today's theme is about atmosphere. Now, before I invite our today's speaker, I'll again, for the students who are joining us for the first time, I'm again repeating yesterday's our introduction about ARIES and the National Science Day. So let me just share this. Okay, so I hope you all can see my screen now. And so again, this is our second day of our National Science Day celebration week that we are having over here. And so, as you know, 28th February is the National Science Day celebrated in India. So, and it is celebrated because Sir C.V. Raman, who was a very eminent scientist in India in 40s, 50s, and so on. So he discovered something called as Raman effect in 1928. And for that, he got the Nobel Prize in Physics, the first Nobel Prize in Sciences for India in 1930. And to celebrate this achievement and to commemorate this discovery, from 1986, it was proposed that we celebrate February 28th as National Science Day. So from 1987, the government declared that in fact, in 1986, the government declared. In 1987, we had our first National Science Day. And along the same lines, every year we celebrate this National Science Day. And there is a theme selected every year. depending upon various current advances in science, current research in science, and our understanding in science and associated technological fields. Okay, so so for those who are joining us for the first time, so we are located over here, ARIES, Manora Peak, Nainital. Manora Peak is the mountain that we are on, and you can see this is the mountain peak, and we are surrounded by a lush green forest. And we are right now over here in this auditorium. So ARIES, or ARIES, stands for Aryabhat Research Institute of Observational Sciences. Now you may ask, if it's observational sciences, but in the name there is E. So that last ES actually stands for the ES at the end of sciences. Okay, and so and ARIES also is the name of one of the constellations in the sky. If you know the group of these or patterns of stars in the sky, okay, and the path that sun follows in the sky. So sun moves from one constellation to other constellation. So these constellations are known as zodiacal constellations, and one of them is known as ARIES. In our Indian calendar system, that is the first one. Okay, and that's how we have got this acronym. And so these domes, the domes that you see here, okay, so this is one of the telescope. The students who are in person over here will be taking you to see this telescope later on. And so yeah, this is our second campus located at Devasthal. It's about 55-60 kilometers from here. And here we have three of our very big telescopes, including this telescope. It is known as 3.6 meter Devasthal optical telescope. You have already seen the photo when you were entering the auditorium. And it is the largest optical telescope in India. And I already mentioned that optical means the light that we can see, our eyes can see. Okay, there are other telescopes also which see the stars and the universe in different type of light. For example, radio waves, X-rays, and so on. But these telescopes, we use it to see the optical light, the light that our human eyes can see. And later on, we'll be also taking you to see one of the telescopes that we have here at Manora Peak. And it is, as I already mentioned, that it is one of the oldest and still operational telescopes that we have over here. And it is going to complete 50 years this year. So these are some of the photos of actual telescopes. So the outside building that you saw, these are known as domes. These protect the telescopes and avoid the stray light that comes from, say, your vehicles, street lights, and light from, say, buildings and things like that. Because when we look at the stars and planets and galaxies, we are actually interested in only those type of lights. Okay, so so these are some of our astronomical telescopes. And here, so this you can see there is daytime, right? But this is a solar telescope. This looks at the sun. Okay, unfortunately, it is a bit cloudy today. Otherwise, we were planning to show you the sun also from the telescopes. Hopefully on 28th, if the weather is better, we'll do that. Then here you have our atmospheric lab instruments, things called as radar. Then you have this weather balloon launch, which monitors a gas known as ozone, if you have read in your school. So as the balloon goes up, the instrument continuously monitors and sends us the data in our lab. Okay, so that's how we measure it, how the ozone and other parameters are changing as the balloon goes up. Okay. And coming back to this National Science Day. So this year's the theme is integrated approach in science and technology for sustainable future. And so all these are activities are part of a year-long celebration known as Azadi ka Amrit Mahotsav that has been going on in our country, celebrating the 75th year of India's independence. And in addition, during this week, mainly the science departments and scientific institutes all over our country, they are celebrating it as Vigyan Sarvatra Pujyate, that science is everywhere. Basically, science is related to every aspect of our lives. Okay, and the scientific viewpoint is important for our civilizations, not only just for studying books and things. Overall, it is really beneficial. So this has been going on in the entire countries. Other institutes, other places are also celebrating that. And so we are also celebrating this week in the form of different talks, lectures, online and in-person competitions. So you have already got the details of those competitions from your teachers. And yesterday, our director, he talked about the sun. Today's theme is now atmosphere. So this is very much related to that, okay, related to theme of atmosphere. Now, if I tell you to compare past and present, now this could also be a picture of, say, a village life versus city life, right? But the same place, say, a few centuries ago, might look like this now, right? As our technology develops, our population grows. So earlier, if you had to travel from, say, one place to another place, and if it was far away place, it might have taken you days or even weeks. Now you have fast vehicles, trains, flights. You can reach within just few hours. Okay. So yes, we have developed. There have been a lot of benefits, but are these the only things? Are there any pitfalls or negative effects? So yes, there have been some negative effects as well. So it's not like that, okay, now everything is very nice, or earlier everything was very nice. Earlier, okay, we had less pollution, but as I said, that if you want to talk to someone far away, that was not possible. There were diseases, even diseases which are very minor now. Okay, they were very harmful in the past. So our medical science has also advanced a lot. Our technologies have advanced a lot. Our industrialization has grown, but because of that, it has caused a lot of harms also. So for example, if you compare this cartoon, if you dig below the surface in the past, you'll find things like fossils and seashells and animal remains or human remains. But if you dig below the surface now, what you'll find? Garbage, plastic, things like that. So is this a sustainable future? No. So as this year's theme is integrated approach to science and technology for sustainable future. Our science and technology should be used in such a way that our future is sustainable. Okay. So this is my last slide. So this is our present. Do you want to continue along this line only? No, right? So we have to use and harness our science and technological capabilities such that our future is much more cleaner and greener. Okay, so that we can leave a better environment for our future generations. So with this, I finished this introduction, and now I invite our senior scientist, Dr. Narendra Singh, who is an atmospheric scientist. So he uses, so I showed you some of the instruments earlier, right? So he uses these kind of instruments to monitor various kind of gases, pollution levels, and very small particles which are known as aerosols. Something like this fog and smog that you see, or smoke that you see, how these change, okay, and how human activity affects the changes in this, or how any natural weather event affects that. So these kind of studies he does. Okay, so with this, I invite Dr. Narendra Singh to talk about today's theme, which is atmosphere. Let me just share the screen again. Okay. Yeah. Please.
Thank you, Vrind, for giving an overview of ARIES activities and telling exactly about what the theme for this year was. So first of all, a very good morning to online and offline participants, and I heartily welcome you all who are physically present here, particularly from LPS and Dikshant International. So as the earlier speaker told you that the theme for this year is atmosphere. And atmosphere, basically a field activity, will be followed by weather balloon launch today. So I'll be just going on that line. So as
just make it like
वो दूसरा एक्टिव नहीं है तो some problem.
no, right. No, sir.
But वापस भी जाना चाहिए. हाँ, now it's working. Okay. Yeah. No, this is working. Fine. So, I mean, just to give you an overview that we have to integrate science and technology in such a way that our future is sustainable, right? Otherwise, I mean, from these three examples, I'll try to just give a flavor to all of you or the students who are there online. However, the students are from say 6th standard to 12th standard, so I'll try to keep it as simple as possible, right? So there are three examples, 1, 2, and 3 you can see there, right? So from these three examples, what I mean, simply people can understand that, okay, in first example, you are seeing a formula and then related, sort of technological aspect of that formula. And in second picture, if you see, there is, a lot of different objects, which are some or the other way based on some, one process or one sort of mechanism that we use in daily life. We call them petroleum products, and which are, producing a lot of things. So let me start from the first example. So in the first example, science and technology, when we talk, science is basically what is science? Say in simple language, science is basically a systematic and well arranged knowledge, which is based on the facts. We simply call that science, right? So based on that knowledge, and we have basically 5 aspects of science, 5 steps, if we call. First, we have some problem. I mean, any student whosoever are in school level, college level, or at any level, everybody in daily life, we have some thought process, and we daily encounter some sort of problems, and we start thinking on that. So problem is problem for everybody. It may be of any kind. So science, the first step of science is a problem. That if you have a problem, you will start thinking about that what could be the solution. Then you go to the second level. Then you try to hypothesize it. You try to have a hypothesis that if this is the problem, then how to counter that process. So the process of that problem. So then you try to hypothesize something, and from that, when you then you in your hypothesis, you do a lot of theoretical studies. You try to derive some formula, try to create that formula. For example, we created this formula: T is equal to 2 pi under root L upon G, which is simply the time period of a simple pendulum, right? So starting from this formula, I mean, maybe you are 10 students and 10 people may derive different formula. But then how to, come to a conclusion that the formula derived by different students or 10 students are, saying the same thing. So then we go to the third level. We start doing experimentation based on that formula. We try to collect some data or try to generate some data, whether it is, theoretically generated or say based on some empirical experiments or based on that. So then you start doing that experiments. Basically, once you start doing experiments, then you definitely, once you do an experiment, you will be arriving to some conclusions, right? Now those conclusions will be either right or wrong, but then how to identify that these conclusions are right or wrong? So again, there is a problem with the students or with the the person who is trying to perform some experiment. So then what will you do? That you try to do experiments, try to list down all the results, and then go to the fourth step. And that fourth step is observation. You try to observe that the nature of that phenomenon, whatever you are trying, the nature of that experiment, the results of that experiment, you try to analyze, sort of thing. Observations means you try to use some analogy. Okay, For example, if I'm trying to monitor temperature of this, location, say for 1 month in summer, so more or less you will say that 2 times you will get, one time you will get maximum and other time in the early morning or night hours minimum temperatures. So from that you derive, okay, that in the month of April the average temperature, average maximum or minimum is this, and based on that you try to write a conclusion. So this is conclusion. So finally, based on your observations, you try to conclude those results, and we call them conclusion. So starting from the theoretical aspects, from your hypothesis you arrive to some conclusion. Now this is basically part of science, what you do. Now to perform all those experiments, you have to devise something, right? I mean, whatever is in your thought, you have to perform it in the laboratory, outside, anywhere. I mean, this is kind of field activity, you can say, or a lab activity, you can say, right? So in that process, what would happen? You try to design an instrument like this, whatever you can see here in the first part of this, second part of this picture. So this is basically a, pendulum, we call it, and arrangement. We have a stand and then a clamp, and we hang a string to that, attach a metallic bob, and then try to do, with the help of a stopwatch, try to monitor the t, because we have time, we have the length of the two things are in our hand. We can adjust the time, or we can adjust the length of the this string. So based on that, you will see that we have one unknown factor in this formula, which is g. So once this 2 and pi, these are constants. T and L are also known to you, because this is the parameter in your hand. You can vary it from one value to the other, from one place to the other. You can perform so many experiments like this, and then ultimately you will come to the conclusion that if you have a set of these values, you will try to find the value of g, because this is simple mathematical expression. So from that you arrive to the conclusion that, starting from some scientific hypothesis, you came to a conclusion that the value of g at a given location is this. Say, generally whatever we study in our metric level, or say in your school level, it is 9.8 meter per second square, but it vary from one place to, say, other place, from one planet to the other planet. So that is another challenging aspect, or say technological aspect. So what we integrated here, we had a formula, we had science, but then to prove that science, we use technology. So now, connecting from this picture itself, the technology that we used, is that sustainable for the future? I mean, will this pendulum, or this arrangement of a pendulum, or for this experiment, will continue, say, for another 1 century, 2 century, or say forever, and without harming our environment, without harming us, or without creating any harmful change in our surrounding? So this can be now, if I say that this stand and all these arrangements could be of wooden, because wood is ultimately accessible naturally. We are not creating anything, so it will be naturally degraded or whatever after living its life. So these kind of things we can think of, just to sensitize your mind, that these kind of things we have to think in a way that whatever technological interventions we are trying to create, or we are trying to do, are those sustainable for future. So now see, this was a kind of clean example. I can say that if you have once constructed, created, or manufactured this arrangement, it will go on and on for years together without harming anything. You can put it into a lab, it will continue. So it is not going to harm your atmosphere, environment, anything, right? But at the same time, since human race is evolving, and they have they have been changing for ages, evolving for ages, we are going to the more and more comfort zone. As in the previous discussion, Virendra has told that one side we could see the clean environment of a village, but at the same time very lightful city and very crowded thing. So but then we have moved from one age to the other. So as a part of that, if you see, we have created that, but then that was in technological interventions, taking into account the whatever science aspects we had, and we landed up into so many things that are very, very essential for us, without whom we cannot, without which we cannot survive. Even today you can survive without lunch, but you have to have a phone with you in your pocket. If you lose your phone, you will not eat because everything goes in that. So I mean, these are the changes that we are facing for we are encountering quite often. So here you can see that petroleum products are a great invention of human being, you can say, and all those are naturally available. But the moment you process it, make it to be useful for the human life, you see that the byproducts which are coming out of these petroleum products, you'll be able to see that it is ultimately creating a lot of problem for the environment. Now plastic is byproduct of petroleum products. If you see that plastic has become a big problem for the entire world. Secondly, if you see that all sort of hardware in the computers, mobile phones, whatever we are using, that is also product of a byproduct of petroleum products. So if you see that that is also electronic waste, and all these have become a huge problem for the entire world. I mean, they take 100 to 200 years, even some of them maybe thousands of years to decompose completely, to get into their original form, which was initially there with the nature. So these are, again, of course, one way we made our life very comfortable, but the other way, if you see that the negative aspects of our technological interventions or inventions are leading to another sort of problem in the world. So then this is confined only on the surface of the earth. But if you see in the space also, this is the third example. In the third example, if you see that where you can see the space debris and junk. So whatever satellites we are launching, most of the developed countries, they are launching few satellites every year. Even sometimes they are in hundreds, but then they have their fixed life. They cannot go ever and ever in the space, because they have their electronic setup, everything, every sensor component, whatever used in that part, in that satellite, they are having some fixed life, and they work for some fixed years. But what after that? So ultimately, they are also creating, junk when they are no more functional in the space. So if you see, then space is also going to in that situation. But without that, we cannot survive, because all sort of communication, whatever DTS connections you are having at your home, whatever satellite phones at very, very remote locations like Arctic or Antarctic, where you don't have generally these communications which are based on the ground. So then there you have to have a satellite phones. So, but then this is human curiosity, that we go to very, very unexplored regions and do all sort of experiments and things, right? So in that process, what would happen? That we cannot stop that all of a sudden. So now the role of the younger generation come into pictures, that whatever career or say sort of they take their future. So these aspects, they have to keep in back of their mind, that if they are trying to get involved in some sort of the technology which are complementary to the science. So we have to think that is that technology or is that work that they are going to do sustainable for the future. So this is kind of the entire essence of this integrating science and technology for sustainable future I wanted to tell you. And from these three experiments, you can say that one is quite, you can say that it has no that negative kind of effect, the experiment one, but other things of course are going to. So now coming back to the theme of this, it's not coming back.
No, lower.
Lower. Okay. ठीक है. Yeah, right. So this one. So what is atmosphere now? So now if I ask 10 students that what is the atmosphere, they will give me 10 answers. Somebody will say that okay, it is up to 2 to 3 kilometers in the vertical, other may say 100 kilometers. And may not be a one common answer from everyone, those who are not of that subject, right? So atmosphere is basically nothing but a gaseous envelope that is surrounding our Earth, and due to which the life is possible on the surface of the Earth. And this gaseous envelope, that it has many gases, but abundant gases also are there, which I'll be telling you. And this is if this envelope of the gases which is surrounding Earth would have not been there, the life on the surface of the earth would have not been possible. We would have not been able to survive, or vegetation and anything. So now coming back to the atmospheric classification. So atmosphere is classified in two categories basically. One is based on their composition, that what kind of gases are present in the atmosphere, and second thing, as I told, that how high the atmosphere is. If you go up from the surface of the earth, up to how high you can go where you can survive. So I mean, this is very common thing, you all might have learned in your school days also, that when we go to Mount Everest, we have to sometimes carry the oxygen cylinder with us. Why? So it means oxygen levels are going down when we are going up, right? So I'll give you now what are the regions. I mean, this is one part, of course, classification, I'll come to that later. But what are the region for the existence of the factors for the existence of atmosphere on a planet? So there are two factors. One is the temperature of that planet, and other is the acceleration due to gravity, or the gravitational force on that planet. Because gravitational pull on the of that planet is holding all these gases or mass, whatever is rotating or is available on the surface of any planet. Only due to the gravitational pull, it is bound to stay on that. So if the temperature of the surface of the planet is really high, so the energy, the kinetic energy of the gaseous molecules or any molecule on the surface of that planet will increase. And if it increase to a level that it crosses, or it leaves the surface of that planet, so we call that the escape velocity basically. So escape velocity and the gravitational pull, these are two linked phenomenon to have atmospheric composition or envelope of the gases on that planet, right? Now if you see that these are the formula, that escape velocity is calculated, the velocity of a gas molecule is calculated with this formula. I mean, this is your high school standard. When we read physics in high school or intermediate, you'll be quite comfortably able to learn this. And the other is escape velocity. So if the higher is the temperature, higher will be the your velocity of that gas molecule. So as I told in the very beginning, that the competing effect of these two will decide whether the atmosphere will sustain or the gaseous mass will sustain on that planet. So in case of the sun is a star basically. If you see, I just have taken to quote here that the escape velocity of the sun is 618 kilometer per second. So if you and for in case of the earth, it is 11.2 kilometer per second. If you throw something, or say for example a ball from the surface of the earth with a speed of 11.2 kilometer per second, so it will cross the earth's gravitational field. It will never come back to the earth. So these are the regions that you can think of, that why there is not any other known planet in the solar system or in the universe itself so far which can tell you that which can give you an hope to live there, right? Why the earth is only such a planet? So there are, one is that the competing effect of these two gravitational force and the escape velocity. Other is the kind of the gases which are essential for the survival of human beings. So now I come to the classification of the atmosphere. As I told you that you will be having different answers for all these distributions, whether somebody will say it is up to 6 kilometers, there may say that it is up to 600 kilometers. So but then again we have to use technology to understand, because the science of the entire atmosphere. So it is basically classified into two categories. One is based on the composition, other is based on the temperature. Temperature in the sense, like if you are now in the city of Nainital, or say at ARIES, you are having a different temperature, right? And if you go to Haldwani, you will be having at least 9 to 10 degree higher temperature at Haldwani at the same time. So it means as you are going up, the temperature is decreasing, though you are going close to sun. But those are other aspects. I will not go into that detail because it will take much time. So based on the composition, as we all students learn in our classes, that in the atmosphere we have 78% of nitrogen, 21% of oxygen, and 1% are other remaining gases like inert gases and CO2 and all greenhouse gases, right? But then the role of all those gases also come into picture, but you'll be learning in the due course of time all those things, that this 1%, if you see this 1%, this 1%, it is having actually great importance in terms of, say, sustaining life on the surface of the earth, maintaining that temperature, what we call greenhouse effect, and of course many other pollutants like which are present there in the parts per million, parts per billion, not in that great percentage, but very, very trace amount, and we sometimes call them trace gases or say greenhouse gases. They have huge impact, and we try to study, scientists globally try to study and understand them, that why the global warming is happening nowadays. If you see, so it is basically because the CO2 which is being added by us, anthropogenic activities, man-made activities, that CO2 is consistently increasing, and as a result, we are facing the problem of, say, global warming. Glaciers are melting, sea levels are rising. So all those are the consequences of man-made activities, whether we call it a technological intervention or invention, or say making our life comfortable in a way, but then trying to create problem at the same time in terms of the pollution, right? So this is all about the based on the composition. Now I'll not give much details on that, because these all details are one individual subject. If I talk about troposphere and then stratosphere, so based on the vertical structure of the atmosphere, if I say that, as I told you, that as we go up, we feel difficulty in breathing, and of course temperatures are going down as we go up. So it means there is something happening with the distribution of the gases or the constituent of the atmosphere, which is playing some role in deciding all these temperatures. So based on the distribution of these atmospheric constituent, the atmosphere in the vertical is divided into mainly 4 spheres, we call. So the lowermost is the troposphere, then second one comes the stratosphere, third one is mesosphere, and the last one is thermosphere. Very good, you are all are aware about that. So but then up to what kilometer is troposphere, then what after what kilometer the stratosphere starts, all those things are to be, are different for different geographical regions. So the region where we belong, basically the tropical region, we generally say that, or based on the observational evidences, we say that troposphere extends up to 16 to 18 kilometer, right? And then from 18 kilometer onwards up to about 53, 54 kilometer, it is stratosphere. And then from 54 to say around 90 kilometer, it is mesosphere. And then from 90 kilometers to about 600 kilometer, it is thermosphere. So these are, general information that you have to keep in your mind. And then, when we say do any technological interventions, we have to understand the structure of the vertical structure of the atmosphere, because we have to understand the aerodynamics. While we are launching rocket, we are putting our satellites into the orbits, earth orbit. So all those atmospheric aspects come into picture. And same is as yesterday our director's lecture, you heard that atmosphere is very, very useful, and earth's magnetic field that prevents us from the many harmful radiations or a mass that is being ejected from the sun and entering into the between the these extraplanetary space, or between the sun and the earth, you can see. So that is where the role of the earth's atmosphere come into picture. So these are the things that you have to understand. And as you can see some very salient features of the vertical structure of the atmosphere, that 99% of the atmospheric mass lies within the lower 40 kilometer, or say even more than that. It is more than that, 90% is within troposphere, and 99% of the moisture and whatever aerosols or pollutants we call, those are in the troposphere itself. And then further down, if you go, it is not even going beyond 6 kilometers most of the time. So it is confined within the lowest 6 kilometer of the Earth's surface. All sort of the pollutants, and they are directly linked to us vegetations, and they affect directly or indirectly in many ways. So now this was just introduction about the atmosphere, that because as you are from various standards. So now what we do here in ARIES, particularly the group which I lead here, so you can see that we do meteorological observations. Meteorological observations means, for example, if you have to understand long-term climate, weather, all those things, so you have to monitor 3 to 4 parameters at least every day: temperature, pressure, humidity, and rainfall. All these activities are to be monitored on regular basis. Based on that, we do some we generate some statistics, and we try to formulate some formula that how the weather or the climate in long run changes, all those things, right? So this part this balloon launch is also part of these meteorological observations. So these meteorological observations are again of two types. One is ground based, and other is you can say that spaceborne, or say in situ. In that sense, we can say of three types. One is that you put an instrument on the in your laboratory or outside, say 1 meter or 2 meter above the surface of the Earth. Then other thing, like you put some instrument on the balloon, whether it is a radio sonde which measures temperature, pressure, humidity, and wind speed, wind direction, or along with you can put ozone measuring instruments, right? Or many other things also people are trying. Say, for example, if you want to have information of this black carbon when we have a lot of forest fires and burning, then they also put some instruments to get say 100 200 meters in the vertical, or say sometime up to 1 kilometer. I mean, we call them tethered devices, or nowadays these unmanned vehicles, robot kind of thing, they are sending in the atmosphere. And then second is we do all sort of base profiling. As I told that we make the pollution measurements on the surface of the Earth, as well as we can make the vertical measurement by sending some laser, and then getting the information about that, because this is ground-based remote sensing, active remote sensing. Basically, we send a signal in the atmosphere, get back scattered, and then try to interpret that what kind of particles are there in the atmosphere, right? And then third is radar. We are also having a radar also. I would just like to differentiate in these three instruments. One is that you are making measurements, say for example wind. You have put a mast of 10 meter and an instrument on that. I'll show you outside, and it will continuously keep you giving the information about what is the wind speed and what is wind direction, right? But then what is happening about that, if you want to have them information? So the second stage comes that we put one instrument with some sensors which can give and a GPS on the balloon, and launch it, and it goes up, and it will keep us sending the data that you will be able to see right now. And that once you see that, what would happen, that you will have a snapshot. I mean, you will have a complete information about, say, balloon goes up to 20 kilometer, 25 kilometer. So up to that kilometer, you will be having information about all those parameters which earlier you were making the measurements only on the surface of the Earth. But now you have a complete scan that what is happening. Say, for example, if the wind at this location is coming from Haldwani side, but at say 2 or 3 kilometer above this level, maybe coming from the other side, say the opposite city of the Haldwani, maybe somewhere around Tanakpur, or from eastern side, from Nepal side. But then how do you know that? Because you cannot go up higher up in the atmosphere above a building and then make the measurements. You have to send some device. So we call them in situ measurements. In situation means whatever situation is there, it is sending back us the information. But then we cannot do that the whole day. In the laboratory, we can make the measurements whole day, right? And it will keep giving you data, say 1 minute, if you want to put one at 1 minute interval, 2 minute or 5 minute, whatever. But that is not possible with the balloons. Balloon will give you, once it goes up, one information from one height. So the third level comes that you have a snapshot of the atmosphere. okay, this is the information. Winds are coming from this side, that side, and what is the ozone value of at this altitude. That's how we came to know that. I mean, using the satellites and say the launches from surface, that ozone is maximum in stratosphere, and that protects us from harmful ultraviolet radiations. Those are coming from the sun, right? So, but then, for example, if you want to make the measurements of wind, basically, wind is very important component of the atmosphere, which brings a lot of the pollutants to one location and drives away from that location, right? So, getting information about wind is very important. So, the third level comes the radars. Radars can be operated from ground and round the clock, unattended, and at very high resolution. I mean, you can have a data at 1 minute, 2 minutes, or 5 minutes, depending upon our requirements. So balloon can give you just one time. If you are launching it at 11:30, you will get information within that 1 hour. It goes up and come down, or one and a half hour, right? But the radar can be operated in day, night, and in rain, in all conditions. And if it is having heavy rain outside, you cannot launch a balloon. So it will not go up, and it will be, as long as it is within the rain or cloud, it may lose data and have a lot of problems. So mostly we try that if there is not a extremely bad weather, we don't launch it. Then, of course, we are having satellite-based observations. So this is nowadays, as I told, that number of satellites are being launched every year. Some are for weather, for communication, and we are getting backscattered. I mean, they are generating a lot of data. So this is open source data. Anybody who is, I mean, interested to analyze that and get some information, this is also, or these are also, I mean, very common studies nowadays, that we cannot put instrument everywhere. So satellites play or complement that, information from the spaceborne observations. And then, of course, high resolution modeling is sort of, it's not that kind of modeling what we talk about. It's a different model. Modeling means we have some formula, equations, as I told, that based on the science, and then try to implement it for a bigger system. So we put all those equations on the computer and make computer to calculate the values for us, the information. So we basically, it is a tool based on the science or the equations, right? So these are the kind of studies that we carry out here. And for your information, as I told, that we monitor pollutions also. I mean, PM 2.5, which is a very essential component when you in the newspapers, and most of the time you see in winter that Delhi air quality has gone very poor, 600 microgram per meter cube, and sometime up to 1000 microgram per meter cube. It some crosses the limit of the instruments also, right? So we can compare that. First, I would give you just an information that WHO, World Health Organization, has some limits set for the different pollutants. So PM 2.5 is basically that goes inside our body with the respiration. So that limit decided by WHO is I mean, for 50 microgram per meter cube for say 24-hour average. But then if you take the annual average, it is 25 microgram per meter cube. But most of the cities, if you visit or you see the measurements, they are never below 50 microgram per meter cube. They are mostly high. Background levels itself are very high. So here in Nainital, we can say that we are breathing much better air, right, in terms of the pollutants. So here you see that these are 2 years of observations, and in the daytime, of course, we are having high values going up to 30 and say 30 to 40. These deviations, you can see the bars here. But then most of the time we are within 25 microgram per meter cube. But these are some observational, based on the observational aspects. If you talk to the doctors or say the epidemiological studies, it is the recommended limit for PM 2.5, which is generally not quoted because it's very difficult to achieve that level. And very few places must be having that. It is 5 microgram per meter cube, right? So if the amount of PM 2.5 is higher, then of course it's a very ideal situation. It's never going to be for any even a town or small town or villages also nowadays, because we have a lot of things for our comfort. So and they all use fuels and many other things. So this is basically the values that you can see here in different seasons. Now, this is how we launch the balloon. We can. This is a small video for you people. Yeah. So you can see that there are two small antennas which are used for getting signals back, and the balloon is being filled with the hydrogen, and instrument called radio sonde is attached to that and launched into atmosphere, and it gives us continuous data. Yes, this is how it goes up, and you can see that instrument is attached to that balloon. This is actually another movie where you can see our radar facility also, because if you want to visit and see physically while going down to Haldwani, on the way right side there is a building and you can see antenna over that. So this is radar facility, stratospheric tropospheric radar facility. So if you really have time and want to visit, you can physically visit there today itself. But for your convenience, I have a short movie, and it has all instruments that I generally work upon and use. And these are the antenna kept on the rooftop. You can see in the first picture, in the first part, you could have seen the entire floor there antenna. This is the middle floor where you can see these are the boxes and hanging there. Two type of boxes. One is power supply. Other is a electronic box, which is used for the data signal transmission and reception. And this is a radar control room where the entire system is controlled. When to send a signal and when to stop it. So this is a radar room, and this is how this is on this screen. Whatever information is coming from the atmosphere is recorded in this room. On this screen, you can see. So this is ground floor, and of course the beautiful and clean weather or atmosphere you can see here, which you will not be able to see in the cities. And this is a dust sampler which gives you the total weight of the dust or loaded dust in the atmosphere in microgram per meter cube up to 10 micron size. This is for, we call them PM, particulate matter 10 micron, right? The particles of size equivalent or lower than 10 micron. And then other instrument is for the same purpose, which this is for 2.5. There are filters for 2.5 and 10, so it gives PM 2.5. But then this is based on the gravimetric. You put a filter and keep collecting for 24 hours, then you will have a 24-hour value. Whereas this one is optical device which gives you continuous information, right? We have a LED inside that, and that LED when crosses the path of air, so based on the attenuation, we try to calculate that, and this is how on that screen you can see that instantaneous value of PM 2.5. Even now you can see in our lab, because we are running this instrument, and this is again a lidar that you could see that we send a 532 nanometer green light in the atmosphere. The laser that you simply use in the night time, red, green. So that green is 532 nanometer wavelength of that green light. And these are of course beautiful views of Nainital. Quite often we see in the monsoon, clouds rise up, sink the other side, depending upon the wind, where it is coming from. And these things keep on going here. So that's it from my side. And I would request the participant, if you have questions, I'm happy to answer your questions and queries.
Thank you, Narendra. So we are a bit delayed on time, but we'll have a couple of quick questions. First, to the students present here. If you have any questions, please feel free.
Yeah, any
Yeah.
doubt in your mind, you can ask. No
Yeah,
issue.
don't worry, it is not an
Yeah,
exam.
it's just
If you
an
feel like
interaction.
anything,
Yes,
like what
please.
sir talked about, you
Sir,
can ask.
I am Anurag from Longview. Sir, what is simple pendulum?
When you come in 9th class, you will have to do one experiment. You are in which class now?
6.
Yeah. Simple pendulum, as I showed that picture, that it is an experiment to, it is a device basically used to calculate the value of G. G is acceleration due to gravity, right? Now, I mean, you might be reading it in your classes like G is equal to 10 meter per second square. But how does it come? You can do an experiment. So that pendulum is a setup. Pendulum means a bob, if you hang with a string and it start oscillating, we call it a sort of pendulum, right? Yeah.
In some clocks, you can see a thing, moving like this, hanging below the clock.
Yeah, those are
So,
pendulum. In
something
the
like
clocks, in shops, you might have seen. घर में जो आती है ना दीवार घड़ी, उस पे वो टिंग टिंग ऐसे चलता रहता है, वो भी pendulum है. Yeah.
Sir, thank you. Sir, I am Debadas. Good afternoon, sir.
Yes,
Sir,
sir.
I am Debadas from ARIES, and I am in class 8. So my question was, there are two classifications of atmosphere. So, sir, what is the second classification?
Second is based on the thermal structure of that how does temperature changes in the vertical. As I told that if you are at Haldwani, you will have a different temperature. When you come here, you will have lower temperatures. So in the troposphere, when we go up, temperature decreases at the rate of 6.5 degrees Celsius per kilometer. So you have to remember that you start from Kerala mean sea level, and we are at Nainital now 2 kilometers above mean sea level. I'm just trying to give you an example that roughly you will be having 13 degree lower than the temperature that was at the mean sea level, say at Kerala, maybe 30 degrees Celsius. So
Yes.
if you can simply subtract, 15 degrees. So of course we are 15 degree lower than the temperature which was at Kerala. So it goes at the rate of, as I told, 6.5 degrees Celsius up to tropopause. But after that, it starts increasing again. So means based on the temperature changes in the vertical, we have defined these spheres of the atmosphere.
Yes, sir. Thank you, sir.
Next one.
Sir,
Yeah, him first. He had raised his hand.
I'm Ashwin, the junior from class 8 12th. So my question is, why does air pressure gets low when we move up on altitude?
Yeah, why does air pressure changes?
Yes.
Pressure from mean sea level. See, if you consider this room as, say, for example, atmosphere, and you try to mix many things together, right? Heavier, lighter gases, for example, and leave it to, like that. Just I'm trying to give an analogy here. Close the door, and you are somehow able to see that nitrogen is of say blue color, oxygen is of say white color, and give some different colors to all compositions. And first you mix, and then what would happen? Ultimately, the heavier molecules will settle first, because heavier mass will be attracted by the gravitational pull, faster, right? So they will settle first. So what would happen in that process? Ultimately, a situation will come where you will have a different distribution in the vertical. So the pressure which is being exerted by that mass in that column at any surface will vary. Say the highest pressure will be at the lowest level, because it is acquiring, it is having the mass in that entire column. But if you leave, say, as I told you, that if you leave Kerala and you come Nainital, so it means you have come, say, 2 kilometer column, you have crossed and you are coming just above that. So what would happen here? That density will be lower than
yes, sir.
what it was at the bottom of that column.
Yes.
So if the pressure density, these are decreasing exponentially, and pressure is basically force exerted by a mass on an area. So if the mass is less, already you have crossed some column, you have left some mass just below that location. So definitely your pressure will be less at that place. So that's how you can understand that pressure changes in the vertical.
Yeah.
Is it clear? Yeah.
Sir, what is the meaning of acceleration due to gravity?
Acceleration due to gravity means See, I mean, you have a motorcycle, or you must be using your scooty to run. You try to drive faster. You just increase the accelerator, right? So there you are accelerating, right? Means you are increasing the speed rate, right? But here, in case of acceleration due to gravity, means if you are dropping or simply leaving something from a higher altitude than the surface, what would happen? Something is which is attracting it at its own on the towards it. So Earth is trying to attract everything towards its center. So what would happen once you release it? It will automatically keep on gaining some speed. In terms of speed, I try to explain you. So it means the rate at which speed is changing is acceleration, right? So acceleration due to gravity means if you are dropping something, either throwing or simply releasing, it will have some automatic effect of the gravitational force of the Earth, which is trying to bring it down to center of the Earth, right? So that is acceleration due to gravity. This is not due to us. We are not giving pushing our accelerator high. It is because of the gravity. So acceleration due to gravity. If you are driving your bike, it is acceleration due to you. So you can simply.
Thank you, sir.
Yeah.
So my question is, in the slide that you showed the layers of the atmosphere, why didn't you mention the layer exosphere?
Exosphere, that's a good question. you have read more than me, huh? So see, anything out. Yes, exosphere means, I mean, we are talking about the atmosphere. So whatever, whenever, even say up to 600 kilometer, what we talk about, even an ionized particle or say electrons, there mostly it is plasma or very low density plasma, you can see up to 600. We assume that after that, if there is nothing, that is exosphere or space simply. Everything beyond that is exosphere, which where atmosphere ends. After that, it is exosphere. So I mean, we are least concerned about that. Exit. Yeah.
I mean, you can always talk about like after exosphere. So there is the space between the planets or the
Right.
space between Earth and the Sun.
So it
So
is
there
a
is
space
also
simply.
something
I
going
mean,
on.
it has limitless or endless, you can say.
So here we were only talking about mainly
Atmosphere.
the lower atmosphere.
Atmosphere.
Yes. Yes.
Sir, I have a question in astrology.
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 It is related to you.
Okay.
Astrology.
So
No,
let us keep
astronomy.
it to atmosphere right now.
So tomorrow, I think.
When we see the telescope, that time we can ask about astronomy.
yeah.
Okay. Let us keep it to astronomy atmosphere.
The students the exact place where ozone layer is there, or is it in the form of a layer, or is it in mixture with the troposphere and the stratosphere?
So
How
see,
is
the
it?
layer means we call that, when we go higher up in the atmosphere, so there is a region between 20 to 25 kilometer, right? So between 20 to 25 kilometer, layer means it is not like fixed. It is the concentration of that particular gas is confined within that region. So we can assume that it is a layer. So it is somewhere between 20 to 25 kilometers.
So it's between troposphere and stratosphere.
Purely in the stratosphere, yeah.
Or
In the
is it a part of
stratosphere.
stratosphere?
Part of
This
stratosphere.
is a very big problem because
No, this is part of the stratosphere, specifically part of the stratosphere. Yeah.
so it is a part of a
Yeah,
stratosphere.
in troposphere also we have ozone, but on surface. Their mechanism is different, the formation mechanism. Here it is a pollutant, but there it is a life-saving, guard, you can say.
Any other question? One last question, if you have. Yeah.
Yes, sir. So how do the ozone layer counter the ultraviolet rays of the sun?
How ozone layer? Yeah,
Yes, sir.
because see, very good question, right? So there you have to now. I'll not go much into detail, but there are various mechanisms of interaction of the light with the matter, right? So matter means liquid,
Yes, sir.
solid, and gas. All three. These are matter. So ozone is present in the stratosphere. So whatever UV radiation is coming, its wavelength is basically equivalent to that the size of that ozone molecule. So when it enters, the photon that hits or the particular wavelength that enters to that ozone molecule, so it somehow get blocked. Of course, the temperature will re-radiate into some other wavelength. Temperature will get slightly increased, but it doesn't allow that photon directly to cross that part of the atmosphere and straightway reach down to the atmosphere. So this is basically the part of the interaction of the matter with the light, right? More details, if you, I can explain you in that way that what mathematical formula has to be, but simply you can understand this way that suppose if somebody is of your size and it hits you, you will try to make fight with the person of your physical structure, and so then it will be a balanced fight kind of thing. So similarly it is happening. So the wavelength which is coming is equivalent to the size of that ozone molecule, and it is not allowing it to pass through. If it is a very small or very big, it will simply either go between the legs or it will simply go above the head. So if somebody has to cross you, you have to be of the equivalent size. That we can understand, right?
Yes, sir. Very nice analogy. Okay, so online participants, students will have just maybe a couple of questions. So if anyone has any question, please raise your hand. Or otherwise, we will take a short break then.
So yeah, we will launch balloon now.
Yeah.
I think our setup is ready.
Okay. Yeah.
Yeah.
Students, online students, any questions?
I think their questions have been asked by the students present.
Okay.
Here.
Okay, fine. So now we will have a very short 5 minutes break, and after that we'll have a balloon launch. Okay.
Yeah.
So you
It's
can take a
already,
5-minute break, and then you can come back to your phone.
Already ready. It's there.
Yeah, you can see here
it's ready.
that this
Launch is ready.
Yeah, so here you can see that this over here you will see the balloon. Okay, so we'll take a 5-minute break. You can come back after 5 minutes. Okay, online students, and then we'll have the launch. Okay.
Yes, sir.
Yeah. So now we can go out. बैलून वाला कब स्टार्ट होगा?
So all of you are present, right? Yeah. So are you able to see? This is balloon, right? And this balloon is filled with hydrogen because hydrogen is lighter than the air, whatever air, because this is not the air that we are, breathing is not only oxygen, it is having all sort of the components. Air is a mixture of nitrogen, oxygen and other things what we just discussed. So it is filled with hydrogen, helium or hydrogen generally, because helium is little expensive than hydrogen, so generally we use hydrogen and more lighter than.
इसके बाद होगा ना स्लोगन राइटिंग कंपटीशन एक स्लोगन लिखना है स्लोगन निकला होगा उसके बारे में सबसे बोलिए कि सबको म्यूट कर
Hello Javed, can you mute the participants which are online?
पता नहीं
This this is basically a radio sonde that you are able to see, and it is having sensors for temperature, humidity. This is for this is your transmitting antenna, and you are having sensor here, you can see, for humidity and temperature. So yeah, so we are not using ozone measuring instrument on this, because that is used for different purpose for the measurement of the ozone, and we are just using for the measurements of temperature, pressure and humidity, along with since it is having a GPS also, which is linked to the satellites, and with the movement of this balloon and changes in the XY coordinates, we can say latitude and longitude, we calculate the drift or the direction of the balloon, and from that direction we calculate the wind direction, and from the speed of this movement of the balloon we get the wind speed also. So all these are already put into a software, and we'll directly get some value for one parameter in the laboratory. So what we do now, we will release this balloon. Ma'am, you can hold that. Yeah. And we'd like you people to launch this. Our students also, you can say join. Yeah. Yeah. छोड़ना नहीं, पकड़ के रखना, अभी वो तेजी से भागेगा. हाँ या हाँ, थोड़ा इधर को आ जाओ. हाँ, ये क्योंकि यहाँ टावर के बगल में है ना, सो बस इसको होल्ड करके रखना जब तक आपको बोलेंगे नहीं, यू आर नॉट सपोज टू लीव इट. हाँ या बच्चों थोड़ा इधर आ जाओ, थोड़ा और ऊपर आ जाओ. या
मैडम जैसे
बस
बस तो आप एकदम छोड़ दीजिए, पकड़ना नहीं, आपको नहीं पकड़ना है.
हाँ
छोड़ देना है.
हाँ,
एकदम छोड़,
अपसाइड डाउन है, इसको ऐसे रखना है. या एंटीना नीचे को ट्रांसमिट करेगा, ऐसे रहेगा. बस आपने जैसे बलून जाएगा वो खुद ही बहुत झटके से अपना ले लेगा उसको. हाँ हाँ, आप लोग भी इधर आ जाओ बच्चों. हाँ नहीं, यहाँ पे आ जाओ, साथ में आ जाओ सारे. आई थिंक ऑल आर इन द
तरफ हो जाओ, पीछे को.
All are in the field of view of the. Yes. Yes, we can. So this will go up in the atmosphere as long as it will keep on expanding, and then ultimately it will burst. So when it bursts, it will start falling down. So it will give us data while going up as well as while coming down, both way. So that is how we get a complete profile of the atmosphere to the height it goes and comes back. Yeah. No, it's not required. Yeah. So shall we launch? Yeah.
Yes, sir.
So 1, 2, 3, go. Go. Yeah. 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 You can see it is going up. So as long as clouds, it doesn't enter into the cloud, you will be able to see it. Yeah.
Sir, how does it come down?
When it, as we were talking about the pressure, that pressure decreases, right? So as the pressure decreases in the, yeah, it will, it might move depending upon the winds up to say 30-40 kilometer away towards the east side, right? This is your west side now, north, no, south. So it is going to which direction? Can somebody tell? Yeah, it is going towards northwest.
So then you make a new one.
Yeah, every time we have to make a new one, because it will, it may fall somewhere in the forest or no man's land.
So what about that?
Sensor.
That is radio sonde. We call that radio sonde package. It is having sensors for temperature, pressure, and that that tail or sort of attachment in that is antenna, basically wire antenna, you can say, right?
So what is the material that balloon is made of?
This is rubber, basically. Yeah, rubber balloon. We call them rubber balloon.
Sir, how many helium tanks?
Huh?
How many hydrogen tanks you need?
Yeah, how many? Because hydrogen is filled based on the pressure gauge. So we fill 35 bar pressure. Yeah.
So just as you measure length in
Yeah. So I mean that unit
centimeters,
is 35, 30
so
to
for
35
pressure, there is
yeah,
something called as bar.
bar. So
Okay.
yeah. So 35 unit. You simply remember it is 35 unit that we are. Yeah. So yeah, west.
This direction, so this means the
Wind is coming from that direction. Correct. Yeah. Yeah. So as
From this direction.
yes. So this is north and this is basically south. So it is east. So it is going west. So basically western side it is going. Yeah. So it means the winds are coming from
the east.
west.
No, west.
Yeah. No, coming from east. You are right. Coming from east. Coming from east.
Sir, when
Yeah.
it comes down, so what happens to that radio shunde?
That can be used, but it is difficult to recover. If it falls around say 60-70 kilometer, so who will bring it? And why he will spend so much money to bring it here? If somebody gets it. So, for ozone also sometime we recover 5 up to 5%. Not more than that. So, if you launch 100 balloons, say over a year, you will get only 4-5 balloons back. Instrument. Yeah. So it is just that's why radars are required. That once you launch it, the cost is too high. So it costs more than 15,000 one time.
Students watching online probably will not be able to see now because it had become very small. So we moved it towards the participants.
Yeah.
But now from here we can still see the balloon.
Yeah. It has yet not entered into the cloud, and clouds are not that deep
On that
there.
side, clouds are not.
Not that.
Sir, in which layer of the atmosphere will it be now?
So it is still in troposphere. Yeah, you can see that at what height it has reached. We can see on the screen inside the computer. If you want to see, it is there inside the lab. Yeah, on the computer you can see that what is the temperature, how it is changing. Yeah. In the groups you can go 2 to 3 students at one time.
Wait, dear children.
Yeah.
Just 2 to 3.
I think now you can disconnect it. Yeah.
Slowly.
This part is over, so you can disconnect it. So you go in the groups, 3 students or 4 students one time. Yeah. And you will be able to see the values of the temperature, pressure, and humidity at a given height.
You can tangle in it.
Yeah.
Okay. So we'll call very few of you
Yeah.
at one time, and then you can go. Okay, 4 students can go.
हाँ, अगर ये हो गया आपका हाँ फोटो भी आ जाएगा मतलब दोनों चीज हो जाएगा.
Okay, now students, so I think while using the app. So okay, students, I think now we can stop this online one.
Yeah.
Because our balloon launch has finished. Remember, again on Monday at 11 a.m. we'll start the same activities. The Zoom link will be same. Okay, and on that day we'll talk about astronomy and
Other interesting topics,
engineering things. Okay, so that's all for today. Goodbye. See you on Monday.